2024. So I will first I will design about the background study. So our background study is hydraulic channel. So the hydraulic channel are designed to provide safe and efficient water flow. Used for irrigation, water drainage, water distribution, agricultural industry. Engineer design the size, slope and shape of channels. Proper design ensure smooth water flow, no environment damage, and then design consideration. And then what is the important factor is first, water carrying capacity, and number 2 is flow rate, the water. And then the common material used is like concrete, rock, and then the channel shape influence water flow. So you can see the design and then the shape influence the flow rate and so on. Then types of the channel is trapezoidal and rectangular. So good design are proven water overflow, channel erosion, and then the environmental protection help protect surrounding ecosystem. Modern design aim to maintain clear water, reduce environmental damage, blend with natural surrounding. Proper planning allow efficient water management, reduce risk, environmental sustainability. So that's all for background study. So I will explain about the objective of the project. Alright, for the objective of the project is, for the first table is learn how to interpolate data using Simpson'S rules. So we need, for the first, we need to determine use the what type of the Simpson's rules. And then for the number 2 is learn how to use Simpson's rules in practical situation. So we need to apply in real situation and then find the real problem, and then we solve using the Simpson's rules. And then learn how to utilize numerical methods in civil engineering domains. So that's why we need to find the flow rate and then how the eliminate can solve this problem using the numerical method. So that's all for our objective for this project.
My name is Muhammad Khairul bin Hashim. My metric number is CF240201. Today I'm going to present about the problem statement if we don't use the Simpson 1/3 rule. Safe and efficient water conveyance is a critical aspect of water resource management. Poorly designed hydraulic channel can cause a range of problems such as water overflow, soil erosion, and sedimentation. This issue not only threaten the stability of infrastructure but also lead to financial loss, disrupt local communities, and harm the surrounding environment. Ensuring proper channel design and maintenance is therefore essential to protect both human activities and the ecosystem while promoting sustainable water management. Next, I'm going to present about the literature review. Simpson's 1/3 rule is a numerical integration method used to approximate definite integral when analytical solutions are difficult or impossible to obtain. It approximates the function using a quadratic polynomial over an even number of sub-intervals and computes the area under the curve using weight function value. Based on the previous study, Simpson's 1/3 rule has been widely applied in numerical analysis due to its ability to produce more accurate results compared to simpler methods such as the trapezoidal rule, particularly when dealing with smooth and continuous functions. Several research have highlighted that the use of quadratic interpolation allow this method to better represent the curvature of a function, thereby reducing numerical error. Consequently, Simpson's 1/3 rule has been commonly adopted in engineering and scientific research for solving integration problems where efficiency and accuracy are required.
Assalamualaikum and greetings. My name is Muhammad Imam Hakim bin Azlan. My matrix number is C4340061. I want to discuss the methodology of our group. Simpson rule is one of the numerical integration subbranches that used to define the function of integration. Since some of the integration problems are analytically harder or more to impossible to solve normally. So this kind of method will be huge help to solve the problem. Throughout many functions, since Simpson rule use quadratic polynomial to approximate the integration. Hence, it is far more accurate than trapezoidal rule. Based on the flowchart step. Step 1. Interpret the interval. Step 2. Determine the number of sub-interval. Step 3. Calculate the step size. H equal to B minus A divided by 2. Step 4. Evaluate the function at the selected point. And the step 5 and the last step. Execute the numerical integration. That is Simpson's 1/3 rule. By applying this step, we can achieve a smooth yet continuously function. So we can achieve accurate estimate for this integral with this method. That is Simpson rule. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noraini binti Hasan, and I would like to share about the calculation on these projects. For the calculation, we already choose the question for this project. So the question is a hydraulic channel is a trapezoidal cross-section with base width of 6 meter and side slopes of 1:1.5 for the horizontal and vertical. So the depth of water is in the channel is 3 meter. So the velocity distribution across the water surface is given by Vx equal to 2 plus 0.4 x power of 2 meter per second, where the x is horizontal distance from the left edge of water surface. The total surface width of the channel is 50 meter. So for this calculation, we use the Simpson's 1/3 rule is used to estimate discharge through the channel by dividing the surface width into the 6 equal intervals. So for the step 1, we must know the side slope, base width of channel, depth of water, total surface width, velocity distribution, and number of intervals. We already know the side slope is 1:1.5 for horizontal and vertical. Base width of channel B equal to 6 meter. Depth of water is 3 meter. Total surface width, which is 50 meter, and velocity distribution is which is Vx equal to 2 plus 0.4 x power of 2, and the last is number of intervals, which is 6. For the step 2, we have to determine the interval width. We know already the interval width. We need to divide the total surface divided number of interval, which is 50 over 6. We will get the answer 2.5 meter. So for the step 3 is we have to determine the Simpson rule, which Simpson 1/3 rule, which is the integral from 0 to 50 of fx dx is approximately equal to h/3 times open bracket f0 plus times the sums from I equals to 1 to n minus 1 of fi plus 2 times the sums from I equals to 2n minus 2 bracket. The step 3 is determine the Simpson's 1/3 rule. So the integral from 0 to 15 of fx dx is approximately equal to h over 3 times open bracket f0 plus n plus 4 times the sums from I equal to 1 to n minus 1 of fi plus 2 times the sums from I equals 2 to n minus 2 of fi close bracket. Next, we have to use the schedule to find the odd and even by using the bx equal to 2 plus 0.4 x squared. So, from this we can get the sum of the odd, which is 4.5 plus 24 and 24.5 plus 64.5. The answer for the sum of the odd is 93.5. And then we also can get the sum of the even, which is 12 plus 42 equal to 54. And then we have to do the application of the Simpson's 1 over 3 rules. The integral from a to b of fx dx is approximately equal to h over 3 times open bracket f0 plus fn plus 4 times the sum of fi for odd I from 1 to n minus 1 plus 2 times the sums of fi for even I from 2 to n minus 2 close bracket. And then given h equal to 2.5, a equal to 0, b equal to 6 meter. So substitute the value. The integral from a to 6 of fx dx is approximately equal to 2.53 multiplied by open bracket f0 plus fn plus 4 times the sums of fi for odd I from 1 to n minus 1 plus 2 times the sum of fi for even I from 2 to n minus 2 close bracket. Next, we have to substitute the total of odd and even value in the formula. So the sum of odd terms equal 93.5 and the sums of even terms equal to 54.0. So by using the Simpson 1 over 3 rules, the integral from 0 to 15 up to plus 0.4 x squared is approximately 2.5 divided 3 times the quantity of 2 plus 92 plus 4 times 93.5 plus 2 times 54.0, and then simplify the brackets, which is this equals to 0.5 divided 3 times 576. Therefore, the approximate value of the integral is 480 cubic meter per second. So, and the last is calculate the average velocity, which is velocity v equals to integral from 0 to 50 of fx times the width of the channels. Substitute the value v equal to 480 divided by 50, which is equal to 32 meter per second.
My name is Najia Atika binti Zairi. My matrix number is and then for the conclusions, to conclude, this project is successfully applied Simpson's 1/3 rules to estimate the discharge in trapezoidal hydraulic channel using a given velocity distribution. So the objective of the study was achieved by this demonstrating how numerical integration can effectively solve in civil engineering problem when the solutions are impractical. So the results were consistent with fundamental hydraulic principle indicating that Simpson's rule provide accurate and efficient discharge estimation for smooth and continuous velocity profile. So, in addition, this study ensures how understanding of how channel geometry, velocity distribution, and interval selection is influenced calculation accuracy. For display limitations such as the requirement for an even number of intervals, Simpson rule remains a reliable method for academic analysis and preliminary hydraulic design. So highlighting the importance of numerical methods in civil engineering practice.